Hello, we're going to go ahead and get started with week 3. I hope quarter 4 is going okay for you guys. This video is going to walk you through the week 3 Google Doc. This week, your assignments that are due are the week 3 Google Doc, and then on AP Classroom, it's only part A that's officially due this week. However, I strongly recommend that you work ahead a bit into week 4. There's going to be a lot scheduled for that week. Maybe I should have put more of it into week 3, but just based off of like the topics, like week 3 kind of goes together and then week 4 is like a slightly new topic within the same unit. But I strongly recommend that you work ahead a little bit, just otherwise it's going to be a lot to do next week. All right, we'll go ahead and get started with part 1. So make sure your Google Doc is ready. For a lot of the lessons for this unit, they're actually like really great interactive lessons that I have to make not as fun because we're doing them all through video, like at couple weeks apart. So we're going to pretend that we have this big jar of beads. It's actually in my classroom. It's in my closet. It's all set. I know the true proportion. But anyway, we're just going to pretend. And each group is getting a random sample of 7 beads from the jar. Let's say that you get you get 20 beads total. Let's say you get 7 red beads. I want you to calculate the proportion of beads that are red. And then I want you to try number 2 as well. Try to identify what's the population, the parameter, the sample, and the statistic. Go ahead and pause, and then when you're ready, we can go over those. All right, so the proportion of red beads is going to be 7 out of 20. And I asked you to write it as a decimal, so that's going to be 0.35. This is p hat. It's the proportion within our sample that meets whatever we're looking at here. It's red. Also, we'll get into this later, but just FYI, this is known as the point estimate for the true proportion. What this means is that we took a sample, we got our p hat 0.35, and that's an estimate, a point estimate, a single point estimate for the true proportion of the whole jar. Okay, so this is a little bit of a review on some vocab. This stuff is going to keep coming up. So population is all the beads in the jar. The parameter is, we use a regular lowercase p for that. It's the true proportion of red beads in the jar. And these go together, and it's useful that they both start with P. Sample is the 20 beads you pretended to pick. The statistic is p hat. It's 0.35. It's the point estimate. So these are just a few different ways we can describe it. It's basically what's the proportion from your sample. So sample and statistic go together. Those also both start with S, so it's sort of helpful to remember. Question 3, you are going to change your point estimate into an interval of values by adding and subtracting some value from your point estimate. The number you add and subtract is called your margin of error. You can choose any amount to add or subtract, but remember, the smallest interval that captures the truth is the winner. So I want you to think about, so we have our 0.35, right? That's our sample statistic. What I'm asking you to do is to create a range that you feel really confident that the true proportion, the parameter of red beads would be captured by that range. So maybe you feel pretty confident. Maybe you want to do like 0.33 to 0.36. That's a pretty narrow range. Maybe you feel like 0.35, I don't know, that was just one sample. I want to like do something that's like a little bit, I want to have a larger range. So maybe you do like 0.3 to 0.4. You pick here. So I'm asking you to come up with what what interval you think would be most likely to capture the truth. Obviously, we could say like 0 to 1. It's going to be somewhere in there, but I'm asking you to try to take a bit of a risk here. What is something that's more narrow than that, but you still would feel fairly confident about? So you can answer that question. What margin of error do you want to choose? Oh, and just real quick on the margin of error, just for my examples here, this first one has a margin of error of 0.01 because I messed that up actually. Let's pretend this is a 4. Let's not pretend. Let's do it. Make it a 4. So this first one would have a margin of error of 0.01 because based off of my point estimate, I subtracted 0.01 and I added 0.01. The second one would have a margin of error of 0.05 because I subtracted 0.05 and I added 0.05. This one, 0 to 1, is not like a symmetrical, it's not like a true, there's no margin of error there because it's not the same amount going from the upper to the lower, so don't worry about that. But anyway, I would like for you to come up with your best margin of error for there. Okay, question 4. Use your point estimate, and we all have the same point estimate because we didn't actually do this as an experiment, so that's 0.35, and your chosen margin of error, so whatever you chose, to write an interval that you think contains the true proportion of beads. So just for some examples here, if your margin of error was 0.2, then your interval, I would subtract 0.2, so I would have 0.15 to, and then I would have to add 0.2 to 0.55. Basically, your point estimate is going to be smack in the middle of your interval. You are adding and subtracting your margin of error to get the bounds of your interval. If your margin of error was, 0.3, just for another example, I would take my point estimate and subtract 0.3 to get my lower bound, and I would add 0.3 to get my upper bound. All right, question 5. How confident do you feel that your interval captures the true proportion? Answer with a percentage. You can decide here. I'm not going to give you an answer. You have to decide. Only you can say how confident you feel about it. All right, so question 6. One of the groups, you can pretend we're doing this all in groups and we're having fun doing math together, has this as their interval. Based off of that, I want you to figure out what would be their point estimate and what's their margin of error. Before you have some work time on there, remember the point estimate is always in the middle of the interval. And the margin of error is how much you're adding or subtracting on either side. So go ahead and pause and try to calculate that. Okay, so when I'm trying to figure out what's exactly in the middle, there is a midpoint formula which you can use here, which is basically you're finding the average of the lower bound and the upper bound. So I'm going to add those up, divide by 2, and that gives me 0.30. Some of you might have also just been able to kind of look at these numbers and figure out it's probably going to be 0.30. So that is my point estimate here. For the margin of error, what are we adding and what are we subtracting in order to get to my interval? So if I've got 0.30 in the middle, what am I subtracting to get to 0.27? What am I adding to get to 0.33? And that is 0.03 is our margin of error. If you are someone who prefers to have a formula rather than just like puzzle it out, you would take your lower bound and subtract your upper bound, and then you would divide by 2. That would also get that for you as well. And mix it up, upper minus lower. And just to see what that would look like here, my upper bound is 0.33. My lower bound is 0.27. Divide that by 2. Let's see, that's 0.06 divided by 2, we get the same thing that way. So you can either use the formula or just kind of think through it, whatever works better for you. All right, question 7. One group claims that the true proportion of beads is 0.25. Does your interval support or deny this claim? So you need to go back up and look at your interval, so question 4, and see, is 0.25, is that included in your interval or not? And depending on what your interval was, it might or might not be included. So you can either say like, yes, my interval contains 0.25, or you can say, no, my interval does not contain 0.25, depending on what your interval was. Cool, so we're gonna go ahead and talk through some notes and then we'll do our check for understanding for part 1. Okay, so a couple things to talk about. One is the point estimate, and we talked about that a little bit in the classwork. It is a statistic, and remember, statistics describe samples that provides a reasonable estimate about the population parameter. And then just a reminder on some vocab and notation. Your point estimate could either be a proportion, p hat, or a mean, x bar. It helps you estimate the parameter. The notation for proportions for parameters is a lowercase p. The notation for the mean of a parameter is the fancy m. Okay, so, oh wait, upper minus lower, no, that was right, okay, cool. Couple other things here. So if you have an interval, a comma b, and this would be like the intervals we are working with during the lesson, there's a couple of formulas you can use to find the point estimate. Basically, you just have to figure out what is exactly in the middle of A and B. To find your margin of error, you would do the upper bound minus the lower bound, all divided by 2. And then I'm probably going to ask you to interpret it. So the way you would interpret an interval is you can say, we are blank % confident. For now, you can kind of make up how confident you feel. There is a mathematical way to do it. We'll learn later this week. Let's see, interval from A to B captures the true parameter context. What I mean by that is like the true, usually it's going to be either proportion or the mean. But just make sure you're using context here. So based off of the beads, I would say we are 90% confident that the interval from 0.3 to 0.36 contains the true proportion of red beads. And then last thing, these intervals that we're talking about are called confidence intervals. And the basic idea with confidence intervals is that they contain all plausible means reasonable, all plausible values. All right, I want you to pause and try to work through the check for understanding. When you're ready, hit play and then we'll walk through it. All right, first part here is asking you to interpret the confidence level. And this is just based off of the notes, based off of what I gave you here. So because it says we're 95% confident, we know what percentage to use. So I can say we are 95% confident that the interval between where are we looking at? 0.352 and 0.548 captures the true proportion of adults who pay for unused subscriptions. All right, calculating the point estimate. So we're trying to figure out what number is just in the middle of the upper and lower bound. So I'm going to do 0.352 plus 0.548 and divide that by 2, which gives me 0.45. That's my point estimate. And then to calculate the margin of error, I'm going to do my upper bound minus my lower bound and divide that by 2. And here we would get 0.098 for my margin of error. All right, last part. Based off of this survey, a reporter claims that a majority of adults continue to pay for monthly subscriptions they don't use. I want you to use your confidence interval to evaluate this claim. Okay, so because our confidence interval contains values that are both above and below, first of all, majority means more than half, right? Because our confidence interval contains values that are both above 0.5 and below 0.5, I suppose I should write this out. Okay. We can't say for sure that a majority of adults pay for subscriptions they don't use. That means that it's possible that it's less than half. It's also possible that it's more than half. All right, so that's it for part 1. Finish that up and then go ahead and start part 2 when you're ready. We're done.